1, go. Hi, everyone. Welcome to Becoming a ROS Developer YouTube channel here in the Construct. My name is Rodrigo. And today we have with us Joe, who did a project with ROS2 Foxy, in which he took our course, and then for his final project, he created a bunch of nodes in ROS2 Foxy that commanded a Turtlebot to do a wall following behavior using the main components of ROS Basics, which would be subscription and publication to topics, and the usage of service and action servers. So, hi, Joe. Welcome.
Hi.
If you want, you can just share your screen, and you can get started with how you did this project.
Okay.
Okay, we can see your screen. Great.
Okay. Wait for me. Okay. This is I use 3 nodes to do this project, and
3 nodes, yeah. Okay.
yes, 3 nodes. So I just to introduce the first node. This node is wall following, and the node wall following is the main node. We'll create 2 slides. One is for server, tells large to find the word, and another one is for action server, tells large to record odometry. And after calling these servers, the robot will go move along the wall. Okay, so you can let's see the video. And the node 2 find the word server will create service server tells large to find the word, and the service slides tells large to stop a record. If the server find the word, receive the request from the site, the robot will start rotating to find the word and to the word in front of it. So you can see it. And if the distance between the robot and the word is bigger than the standard that we set up, the robot will try to near the word, and the distance is smaller than the standard. And then the robot will rotate until the word is on its right. Finally, the node find the word server will call server /stop record. Let the robot stop record automatically. Okay, so the next node, record automatic agent server, will create agent server. The agent server is named /start to record automatically, and the server /stop record. And after the agent server /start record automatically receive the goal from topic /order, and feedback, it can feedback the robot has moved so far as action slide. So let me show it here. Here, so he will feedback the movement, yes. And if the final word is true, if the server stop record receive the request from slide, the agent server will stop all the record and return the result or record automatically. So this is the architecture for my wall follow package. And because I have no time, so I just use this. Okay. And we can use 2 ways to activate the node wall following. One is activating the directory command out ROS2 run wall following. So if you use provide namespace to name the topic in the node, you can find the topic name will follow the node name as shown on diagram. And another take one topic example is launch file to activate the node word following. Do the command ROS2 launch word following the launch.py. This way, let the node name follow the host name of row. And remember, I use provided namespace to name the topic on the node in the node word following. So the topic name will also follow the host name. Take the topic name for example as shown on diagram. You can find the topic name is this. Okay, but if we activate the node word following to the launch file separately, but there's a problem is the robot in ROS2 receive the topic is standable, not the topic list. So how do I modify it, improve it? Well, I using a parameter remap. There are many parameters in function node. And the remapping is a very useful parameter. We can replace the topic, service, and the slide name. From the name we set up in original node to the new name we set up in launch file to the parameter remapping. So you can see the diagram 11. 11 here. I add a variable self cmd to cmd and I give it value in tuple. Tilde slash cmd volt to slash cmd volt. So I put this variable and remapping my topic name and let my topic name. You can see the topic name about here. So the topic name is I want to use.
Right.
So I can use this file, launch file, to launch my node, and the topic is right I want to use. And if we know how to name our topic or node, and this is my constructed node. I use object-oriented programming to construct the node, and I try to make my own solve to build a node. There are many steps. One is the first is configure parameter from ROS2 parameter server and the local parameter. And the two set up a variable for the node. 3, create a communication with ROS2 such as topic, serve slide, or timer, and anything else you want to create. And the 4 is define the callback function corresponding to the topic, service, slide, or timer. And the 5, create the function main outside the class. And the final can run the function main to attach the node file.
Okay.
Yes. And the step 1 is configure parameter. And yeah. Okay, because I use OOP method to create the node, we can use self the declare parameter to declare the parameter in ROS2 parameter server. After that, we can use self the get parameter, the value to get the parameter from ROS2 parameter server. But why do I declare and then get the parameter from ROS2 parameter server? Yes, so this is why. Because I don't want to modify my node very high frequency.
Yeah.
So I want to so I want to use the YAML file, and then I can just
just load the parameters. Yeah.
Yes, and then without rewriting my node.
Oh, that's really interesting.
Yeah. Okay, and how to load the YAML file in launch file? Yeah, where can we get the parameter from the file in ROS2 parameter server? So you can see the diagram 18. You can use the function path and get a package share directory to get the parameters. And then update the value of the same parameter in ROS2 parameter server. Okay, but how do I utilize the function to get the path? So this is the why. We know that ROS2 will build its workspace and get the file from it. But where is it? If you build the workspace just successfully through command build, I think It is located in list. A ROS2 workspace install and your package name share package name. So here, yes. So if I use the command control build, and I can add my YAML file into the shared directory. So that's why I use this function to get the path.
Right.
Okay, so let's look at the blue box in documentation. So you can add something into the list data file in the setup.py in the package. So I added the patch to my YAML file with list. And the list will install the list path in the shell. Okay, so this is the YAML file. Okay, so if I use the launch file to expand my node, I can edit parameters, pit controller config, and this is my path. But there's a problem is this. You can see on diagram 22. The logic does not explain how ROS2 parameter server process data. So hence I create the following process. After I activate the node to the launch file, first the node will declare the parameter. And second,
sorry to interrupt. 5 more minutes.
Yet parameters.
Yeah.
Yes, and second, if any parameters I write in PID config.yaml, it sends as the parameter in ROS2 parameter server. Then we'll update the value of parameters. But if not the same name, well, nothing happens and no moving error is displayed to you. So you should notice this. Yes, and finally, I can use the node to get the latest parameters from ROS2 parameter server. Yeah, that is how I get the ROS2 parameter. Okay, and then we can go to the step to each step will set up the variable, such as the current time distance of the LiDAR with respective angle and the current state of the robot. And the step 3, after setting up parameters and variables, we'll create communication with ROS2. Each step needs to be done as soon as possible. Because I use its name, I will change its name in the launch file with the mapping. So if they are not the same name for the topic service and others in ROS2 between the node and the launch file, you will get the wrong information about the problem. So each step I think as good as possible. Okay, and the next. I take a subscription for example. In notable following, I create a subscriber and the user provide an space to name it. Also, this subscriber will subscribe the topic scan, and its message type is laser scan. When this node receives the topic scan, it will call a function to do something through the parameter callback, and I give it values of the callback.scan. And I will show more detail about this function in step 4. And the parameter QoS profile is setting quality of service, and the parameter callback group is setting education and the callback. And what are the last two parameters doing? The QoS quality of service allows you to turn the communication nodes. This means you can choose which communication policies are better. You can use the command ROS2 topic info and scan and the selection variable to find the QoS of the topic. And I usually configure 2 parameters in QoS. One is deep and the depth for QoS size, and the reliability for best ever over reliable. And executors are responsible for the actual execution of callback and should extend the executor class. I use a multi-threaded executor to activate the notable folding. I will discuss this in more detail in the final step. And the callback groups are used to enforce concurrency rules for callbacks and should extend the callback group class. I usually list the return callback group to be the callback group in the subscriber. This allows callback to be executed in parallel without restriction. And the step is the core of the notable following. The execution order for each function that I use follows the same order ROS2 communication per step 3. Previously in step 1, I explained how to get the parameter from the ROS2 parameter. Hence, the function get the ROS2 parameter is not shown on the diagram 29. And there are 5 main functions in the notable following as shown on the diagram. So let's look at each function in detail. And the first, I create a timer in step 3, and its purpose is to do something at recurring intervals. In this example, I want to update the parameter if I update the parameter in ROS2 parameter server, and check ROS2 parameter server every 1 second. It's very useful to help tune and observe the robot where adjusting PID parameters in the ROS2 parameter server in real time. Okay, before the robot moves along the wall, it modifies the wall first. According to the one node one function in design node, I can send a request to another node to find the wall, not use the find wall in the wall file in the node wall filing. So which is why I create a site for /find wall. And there is a parameter for the site in the function called found wall server, which purpose is to make a SOP to build an external service line and show the information in ROS2 after calling the service successfully. And this is my SOP below. So you can set up the variable slide name for the site and find the name that is related to the variable slide name in ROS2 server list. And check there that the same service exists in ROS2 service here. And then you can use a channel method to send a request to the service server. And as soon as the request was accepted by the server, it will stop processing. And any response to the site will be handled by the callback function. So this is my service side SOP. Okay, and maybe you can see the function partial in the blue box as shown in diagram 31. And this function can return a new partial object, which when called will behave like a function called with the positional and the keyword argument keyword. So if I want to send arguments to the callback function, you can see the example is shown on diagram 33. So that's why I use the partial. Okay, after we send a request, how do we know when it is completed? We can get the response information by setting a handle. Yep, handle here, response.
Excuse me, Joe. Joe,
Yep.
Just really quick, because we're running out of time. Do you mind going to just showing us really quick what the action server looks like, and then we can wrap up.
And I show the PID controller. This is the main idea.
Okay.
And if the robot is the error between the 0.3 and 0.5, it will get a velocity for ghost strike. If not, it will use the PID controller to modify itself. So this is how do I do it. And this is my simple flowchart of the notable filing. Okay, so and the node will be the repeated the motion. So I skip. I just try to here. How do I calculate the distance? So I watch the diagram attitude and the action robot current point is at time 1 and the previous point was at time 0. Then I can use distance formula to calculate distance between current point and the previous point. And because I update attributes solve the action several seconds at the same time, I can use it to be the index of list, self, the odometry, the list of order to get a point. Also, we can accumulate distance between 2 points as the total distance how far the robot goes. For example, current distance equals distance d1 at time 1. Next, the robot goes to point at time 2. And now current distance equals distance d1 plus distance 1, 2. So this is why I can know the robot how far it goes.
Right. Okay. And can we just look really quick, how you implemented that in the code, the action server?
Action server here. If I use a main condition, self action server status. So if the self action server status can control all the action server, and you can see this. If the action server receives the goal, it will let the self action server status equals true, and will feedback is how about the robot go, and will do it. Until this, if the action server get a request from other services line, it will let the self action server status equals false. So if this attribute is false, and this will not do it, and it will go to here.
Oh, okay.
Yeah.
Well, just so you know, we ran out of time, but I think we got the basis covered. And let me just tell you, first of all, it was really good job with how well structured and defined all of these programs are. I mean, you went above and beyond to make sure the system was as robust as possible. And let me just congratulate you there. And then let me ask you, so I have two questions for you. What are the main advantages of one, using namespaces in your topics like you did, which was really interesting, and the obvious, for updating your parameters in real time? And what are the main advantages you see with a program like this that can be complicated more and more?
Sorry, can you repeat again?
So what are the advantages that you know of using namespaces in your topics?
Wait for me. The bounded is here.
Yeah, right there.
Yes. And you mean what's the bounding for the topic or the distance?
So yeah, the advantages of using your namespaces, and what the advantage is of having the parameters available in real time.
Parameters. Can you see the PowerPoint?
Yes, I can see it.
Oh, okay. You mean this?
No, I was just talking about. I was just trying to say that the way that you implemented those parameters to get them in real time is just so interesting and great, because that way you don't have to compile every time, and you can just make that so much more simpler than going and making the changes hard coded. So I was just making a comment on that, and but other than that, I think it's a great project. Do you mind stopping sharing your screen, please?
Okay.
Can you deactivate in Zoom? Can you stop sharing your screen?
Wait for me. How to stop it? Wait for me.
Mm-hmm.
Okay. Okay, I find it. Okay.
All right. I think we have it. Let me just make sure. Okay. Yeah. So yeah, congratulations, Joe. It was a really interesting and well thought out project, to say the least. And just so you know, guys, this can be you. You can create your. You can go through our courses and learn the basics of ROS and ROS2, and we have many other courses, and a lot of them include this project scenario where we try to talk about how the ways that you acquire extra learning from presenting your knowledge. So thank you, Joe, very much, and I hope you learned what you needed, and that you can go forward with whatever projects you have. Thank you, Joe.
Okay, thank you.
All right, bye-bye, everyone.
Bye-bye.
Okay, that's it.